Welcome to Study Loop.
And omega prime is equal to the square root of 1 over LC minus R squared over 4L squared, where R is the resistance in the circuit, L is the inductance, and C the capacitance. But firstly, we want to find omega naught, and omega naught is the value of omega when R is equal to 0. And omega naught is simply 1 over the square root of LC, since we don't have any resistance in the circuit. And these values are known, so we can calculate this angular frequency. So this is 1 over the square root. The inductance is given as 0.45 henries, and the capacitance is 2.5 times 10 to the minus 5 farads. And hence we get omega naught to be 298 radians per second. For the second part, part B, we want the value of omega prime over omega naught to be 0.95, which corresponds to a 5% decrease. And we wish to find the resistance R for which this occurs. So if we take our expression for omega prime from above and our expression for omega naught, we can see that this implies, and we'll square the top and the bottom, so we get that 1 over LC minus R squared over 4L squared all over 1 over LC is equal to 1 minus R squared C over 4L when we simplify, and this is equal to 0.95, and remember we squared the top and the bottom of that fraction to remove the square root signs. So if we rearrange this equation, we can solve for the resistance R, which corresponds to a 5% decrease in our angular frequency. And R from above, if you rearrange, is equal to the square root of 4L over C into 1 minus 0.95 squared. And we have these values, so we can calculate this resistance. And that's simply the square root of 4 times 0.45 henries times 0.0975, suppressing the units here, all over the capacitance, which is 2.5 times 10 to the minus 5 farads. And hence we get the resistance to be 83.8 ohms. When the resistance increases, the angular frequency decreases and approaches 0 as R approaches 2 times the square root of L over C.